now to June. Yes, June 2010, question 8. Question what? 8. We have here two particles, A and B. 1 meter. 1. Now we have two particles A and B. One has a mass 0.4 A. Okay, so 0.4 G, right? And the tension where? Upward. Towards the pulley, always. The tension will be towards what? The pulley. The second one,
0.3 G.
Girls, please stop. 0.3 G. The tension always towards, or also towards what? The pulley. Both of them are tied 1 meter from the ground. Okay. Then, the string passes over a small smooth pulley which is fixed above horizontal floor. Both particles are held at rest with a string taut of at height 1 meter above the floor. As shown in figure, the particles are released from the rest and subsequent motion. B does not reach the pulley. B does not reach what? The pulley. What we are asked, as usual, we are asked about tension and acceleration. Tension and what? Acceleration. Okay. Directly, the motion will be in this way. This is the direction of motion. Okay, it's given in the question, and also because 0.4 G more than what? 0.3 G, right? So what do we have now? For A, if net were downward, yes, equals MA, right? If net, what we have? 0.4 G minus T, right, equals 0.4 A. For B,
T minus
F net upward equals what?
T minus 0.3.
Yes, T minus 0.3 G
Equals
0.3 what? A. Okay guys, it's easy now, right?
Yes, cancel.
The motion for B is upward, so T minus 0.3 G. The motion for A is downward, so 0.4 G minus what? T. Now this is equation number 1. This is equation number 2. Just a minute, please. So we have to add them simultaneously. So 0.4 G minus T equals 0.4 A. T minus 0.3 G equals what? 0.3 A.
So say 0.1 G.
T cancels T. 0.1 G equals what? 0.7 A. So A equals
1.4.
1 over 7 G meters per second square, which is 1.4 meters per second. Okay, guys? So as with the tension, by substituting this value in any of these equations, so we will have tension equals what? 3.36 newtons. Okay, guys? I think here, up to here, no any. This is A and this is what? B. Yes, ma'am.
In M1, bnacles square root, we do plus minus square root, and we got to answers.
Where is square root here?
Not in this question.
Yeah.
Like if you put in a question, square root.
Yes, if x squared equals something, we have to take plus minus.
Plus minus.
Yes. Okay? Okay guys. Now, when the particle, listen, when the particle have been moving 0.5 seconds, the string breaks. Find the further time that elapsed until B hits the floor. Elapsed يعني taking, yes, time taking. Okay guys, listen please, listen. Look to the subsequent motion now. Guys, pay attention please. Now, after 0.5 seconds, let's say B reaches here. Okay? This time is what? 0.5 what? Seconds. Then what will happen? The string is broken. The string is broken. But B will not stop immediately. will accelerate where?
Upward.
Upward until to reach mean?
Why?
No, it does not reach the
V equals 0.
right? It will continue in its motion upward, okay, until it reaches the maximum height. Then it will what?
Decelerate.
Fall down, right? It will fall down. Look here, please. That's my name. In order to explain this, it will fall down.
In that stage 2?
Yes. Again, during 0.5 seconds, during this time, right, there is a tension. The acceleration is what? 1.4. After the 0.5 seconds, the string is broken.
So the acceleration.
And again, yes, excellent. And again, if the string is broken, the particle will not stop immediately. So it will continue moving upward, then it will fall down by means of what? Of the gravity. By means of what? Of the gravity. Down. Okay, this way. Because here the string is broken. Okay, how many stages we have? 2 stages. Stage 1 and what? Stage 2. Be careful now, please. Look to this. In stage 1, we have weight, which is 0.3 G, and what? Tension. Right? 0.3 and what? Tension. Clear? Here in stage 2, what is the forces?
Tension.
Yes. 0.3 G only. There's no tension. Tension now is what? Tension is what?
0.
So this becomes what? Free fall.
So then
No, the string is broken.
I broken in stage 2.
No matter. After 0.5 seconds, the string is broken. No matter where. The main point in here, the string is no longer what? Ch.3, or it's no longer actually acts on what? On B. Now, guys, what we are asked to find time during this. This is stage 1. This is what? Stage 2. This time. Okay, look. This time. Is it free fall? Yes. So the acceleration here is what? Minus 9.8 what meters per second square. Always in free fall, guys, yeah, it hits the ground. But always the free fall acceleration is always what? Negative 9.8. Okay? It becomes free fall. But it's not, we cannot generalize this. This is a special case here because there's no tension. The only force acting on it is what? 0.3 G, which is the weight. So this is why I consider it as what? Free fall. Okay? Fine? Okay. Now, what we have here, U0, right? A 1.4 meters per second.
S1.
Time equals what?
0.5.
0.5. S is not 1.
Why?
This is S.
No.
Okay?
1 plus.
Right? 1 plus what? So, guys, pay attention here. Pay attention. What we have here, information given. Only what? Acceleration.
But V.
Time is not given. V, we don't know it.
But U equals 0.
Yes, so we have to find what?
V.
I have to find V and S from here. V and S here. So it becomes what? Initial displacement and initial what? Speed. Yes, excellent. Or velocity. In other words, and here, V equals what? U plus 80. V equals U 0, A,
1.5. 0.5.
which is equal to what?
0.7.
0.7 meters per second. So U here, 0.7 meters per second. Okay, guys?
Yes.
Clear? Again, the final velocity here would be what? Initial velocity where in stage 2. In stage 2.
And I want to find S.
We need to find what also S. S equals
UT plus half HT squared.
الله عليك. طب هون ما حلو نستخدم maximum height.
S equals UT
plus half A.
plus half AT squared, right? S equals
Half.
U0 half, right? Half
1.4.
1.4.5 squared. S equals
0.175 meters. That's 0.175 meters.
yes, just 0.175.
175.
So total displacement in stage 1. Okay, this is what S total. Guys, pay attention, please. Again, look here, please. Look here.
So they want
From here to here, 1, right? From here to here, 1. Plus what? 0.75. For initial displacement, sorry, 0.5 seconds. Now, I'm talking about what displacement. Please, attention, please, attention, girls. From here to here is what? 1 meter. From here to here, 1.75. So, the initial displacement from the ground, this,
1.1.
instead of saying initial, the total displacement from the ground in the first stage is 1.175. Any question? لا هون. لا. At the moment where the string is broken. High displacement.
كلها 1.1.
high 1.175. لأنه من هون لهون كم؟ 0.175 here 1. Okay? Clear, guys? يعني مرة ثانية. Overall this height is what? 1.175. Clear? Any question about this? Yes.
هلا هي بعد ما وصلت هذيك على الارض السترينج بروكن ولا قبل؟
لا لا هي السترينج بروكن هون.
طب هذيك وصلت على الارض ولا
ما نعرف. هاي ما اللي فيها. We are asked about me. We are asked about me. B. خليك والله معي جاسم. We are asked about what? B. I don't know anything about A. We are not asked about A.
استاذ اذا السترينج بروكن من هون كيف حيطلع؟
احنا بنقول okay بس it will not stop immediately and falling down. It will continue.
Decelerate to zero.
Yes, decelerate to zero. I give you a very common example. And if you are driving a car, okay? If you'd like to stop the car, does the car stop immediately? Same thing. No. Same concept, yeah, Justin. Same concept. Hella, since the car will not stop immediately, similarly, B will not stop immediately. It will decelerate a certain distance upward, stop, then falling down. Okay, fine? This is as a result of Newton's second law. In the second stage, what do we have?
S.
Okay, guys, I will answer you. Look to the second stage track. Guys, I will draw the second stage track. This way reaches what? The ground. Any question about this track? Okay, this is the second stage. And after the string
Breaks.
broken. Broken string. Right? Clear? Type. Is it free fall? Yes. What is U now? 0.7 meters per second. S.
1.175.
Yes.
طب ما احنا لا اسمع ما بنعرفها.
A.
Minus 9.
والله عليها شوي. لا احنا ما طلعنا هاي الاس.
لو قلت بس بنطلع الاس الجديد.
طيب. Excellent. Listen. I would like to explain this for you. Guys, look. What is this displacement?
هاي كلها 1.175.
1.175. Right? Guys, this what? 1.175. If you remember in free fall, I don't care about the path. The displacement is what? The shortest distance between initial position to what? Final position. Right? Which is falling down, so the displacement is what? Negative. Again, pay attention for a moment. Just pay attention. Again, guys. After After the string is broken, the second stage, this is the track of the motion. It's free fall. It's what? Free fall. Exactly like what we did in the kinematics about the free falling. Okay? So, what we did before, if you remember, this is the initial position, this is what? Final position. We always take the displacement, the shortest distance between what? Initial and final, which is what? 1.175. Why negative? Because it's falling down. This is the first point. Second point, U is given, U is found here. The final velocity in stage 2, initial velocity in stage, final velocity in stage 1, initial velocity in stage 2. Now I have USA. Can I find T? Yes. S equals UT plus half 80 squared. S negative 1.175. U 0.7T plus half minus 9.8 times what? T squared. I have to rearrange this equation to have what? Quadratic equation. Quadratic what? Equation. So what I have, what are the values? Okay, here we will get two values of time, one negative and one positive.
0.5663.
0.5663. And 0.57.
Or 0 minus 0.4.
It will be excluded, yes. Any question, guys, about this point? Any question?
No.
Okay, fine. Now, copy this quickly, please. Negative, but it will not be included, okay? Here. Speed time graph, velocity time graph. For the motion. Pay attention, please. Guys, listen, please. Actually here, this question, right, correlate what? Dynamic to what? To kinematics, okay? Regularly or recently, we have questions like this, okay? The previous year. So, let's draw velocity, meters per second, time, what? Seconds. Guys, pay attention. The initial speed was what? 0, right? After 0.5, guys, please listen. After 0.5 seconds, the velocity is what? 0.7. Pay attention. So I put on 0.5, okay? That's in order to show the steepness of the graph. Guys, this is what? Acceleration. Look. The acceleration here is what? 1.4 in stage 1. In stage 2, the acceleration becomes what? Minus 9.8, which is steeper. Which is what? Steeper. This one here. يعني closer to the y-axis or the vertical, right? Closer to what? Vertical. Look here, guys. We don't have values. But the same gradient, right? The same what? Gradient. In stage 2, in the whole stage 2, the gradient is what?
Negative
9.8 negative. So this is what? The sketch for the graph. Here is what? Maximum height. If you are asked specifically about certain time, we have to find what? The final velocity at this moment. And I may find the final velocity. V equals what? U plus 80. V equals U 0.7. This is in second stage. Stage 2. Plus A minus 9.8 times what? 0.57.
The high velocity, it hits the ground?
Yes, it hits the ground. Excellent. This velocity that it hits the ground. What is this value?
0.757.
Yalla guys, quickly calculate this, please.
So the stabilization staying with you.
Hi.
Negative
From here to maximum height, acceleration 1.
Negative
3, 4.
4.8.
لا negative 4.8.
Negative
4.8.
4.9. Essentially.
لا
9.
4.8 ما تاخدوها 7.5.
4.8.
4.8. Okay. No matter. So this value should be what? Negative 4.8. Clear, guys? Guys, beware about these type of questions, okay? Probably we may have a question like this. To draw, to make it, to use a dynamic to solve the question, and eventually we might be asked about what? A sketching velocity time graph for the whole motion, yes?
So the total time is 1.0.
1.17. I mean here, approximately 1.07, right?
Yeah.
Something like this. Okay, guys? Look to June 12. Two particles P and Q of mass 0.3 kilograms. Okay? And the other particle 0.5. This is P 0.3 G, weight 0.5 G. Sorry, this is June 2012, question 7. Come on, guys.
Oh my god.
Does it take like that?
It's given, oh, sorry. Okay, no matter.
Not fresh?
لا لا اوكي خلينا let's do it as the figure.
أنا ما بكتب أفناد أستاذ، أنا بكتب عادي.
عادي صح؟
ما أنا عارفة.
Guys. Actually, they are connected to each other by light rod, okay?
Yeah.
It's not a string. It's not what? String. So, it's rigid, right? It cannot be a slack. Rod means, or tow bar, or rod, whatever. Okay, this means in the deceleration, or in the case of deceleration, okay, the rod is, will not become slack like the string, right? Because it's rigid. Yeah. This is the main point. Okay. Constant force F, 4 newtons applied to the cube. Okay. The system moves under the action of this force until t equals 6 seconds. During the motion, Q and P has a resistive force, one in resistive force, 2 newtons, right? Here we have resistive force what? 1 newton. These are given to you. Okay. We need to find acceleration, speed, tension. Okay. Acceleration, speed, and tension. Okay. So, what are the forces here? We wrote here weight, right? Normal here and normal here. Since it's accelerating,
tension here.
yes, here there is a tension in this direction, here there is a tension in this direction. Okay? Because it's what? Accelerating. Okay? As usual, F4P, for Q, let's start with Q. F net forward equals what? MA. 4 newtons minus what? 2 minus T equals 0.5 times A, which in other words 2 minus T 0.5A. Any question about this equation? This is for Q. For V, similarly, F net forward equals what? MA. F net forward equals what? MA. What do we have here? T minus 1, right?
Yes.
Equals what? 0.3 times A.
Ustaz, and I solved it as a one particle.
Yeah, you can. Same thing. So what is the result now? Do this, but actually you will redo it again. Yes, in order to find the tension. And we have to do it like this. So if I add it together, 2 minus T 0.5A t minus 1.38. T cancels t, right? 2, 1 equals 0.8
A equals 1.25.
25 meters per second. What we are asked to find the speed of the particle. This is A,
C equals 6.
B, V equals U plus 80 direct. It's easy, right? V
is 0.
equals U0, A 1.25
T6
times 6. This would be
7.5.
7.5 meters per second. Later we are asked about what? Tension.
As
C.
the system moves under the action of F.
Yes. Tension, substitute for any of these equations, right?
Yep.
So T minus 1 equals 0.3 times 1.25. So tension equals
1.375.
375, 1.38. 1.38. Guys, here we need only 3 significant figures maximum, okay? 3 significant figures what? Maximum. Now it's easy. Look to part D.
But at T equals 6, F is removed, and
Yes.
the system decelerates the rest.
Pay attention, please. Don't copy anything. I will give you time to complete copy. Please just pay attention. Now, at V at time equals 6 seconds,
F is removed.
F is removed. And as a subsequent motion, the two particles will decelerate, right? Which is mentioned in the question, right? The system decelerates to rest. The resistance of the motion are unchanged. Yani, the resistance for the motion S2 and 1 will be kept as the same. What we are asked later to find the distance moved by B as the system what decelerates. Now, girls, the main point is what?
التنشن رح يتغير.
Yes, here there is a change in the forces, right? Two changes here for the forces. I will show you now. F is removed, right? F is removed. As a result of that, we have to divide the motion to as two stages. Now, look to the subsequent motion now after removing F. Now, what are the forces that here? Similarly, we have 0.5 G R. Here, 0.3 G also R.
في 1 Newton قلنا.
Here, 2 newtons with resistance what? 1 newton. Now, girls, pay attention. If you remember, if there is a rod or 2 bar or whatever, any ratio rod or something like this cannot be slack, cannot be a slack in the deceleration. What will happen here? We have thrust. In the deceleration, the force now is what? Thrust. This will decelerate. So here we have thrust in this way and thrust in this way. Okay, guys? In the case of deceleration, the tension, or sorry, the force in the rod becomes a thrust, but in the opposite directions. Okay, in the opposite direction. Look to the difference. Okay, fine? Here we have what? Deceleration. Okay, as usual, what we are asked to find? Distance. In order to find distance, I have to find acceleration, the new acceleration. I have to find what? New acceleration. Why we have new acceleration? Again, girls, look. This force is removed. With tension, also becomes what? Thrust. And two changes for the forces. Definitely, we will have a new acceleration, right? We have what? A new acceleration. Okay, fine. What does this mean? We have stage 2, and all the calculation here will be what? Stage 1. Okay, guys? Right. The final velocity in stage 1 equals what? Initial velocity in stage 2. U equals 7.5 meters per second.
وفي حتكون 0 صح؟
V excellent لأنه اللي accelerates to what? To rest. In order to find displacement, I have to find acceleration by using Yes, 4. Let's start with Q. This is Q, this is P, صح? 4Q. F net still forward equals what? MA. It's decelerating what? Forward. F net equals what? Thrust, right? Minus 2 equals 0.5 times A.
A equals
This is equation what? 1. Be careful, thrust here is different than what? Tension. 4P. Similarly, F net forward equals what? MA. What do we have now here? Thrust plus minus 1 minus thrust, right? Look, minus 1 minus thrust, because the motion is still where? Motion is still where?
Forward.
Forward. Okay, motion is still forward. Equals 0.3 times what? A. This is equation number 2. Guys, again, if this force is removed, again girls, the system will not stop immediately. Okay, the system will not stop what? Immediately. It will decelerate, or the whole system will decelerate to what? To 0. Will decelerate to 0. Any question about this point? Okay, Jasmine? Okay? Now what we have to do, we have to, yes, thrust minus 2 equals 0.5A, minus 1 minus thrust equals what? 0.3A. Thrust cancels thrust, negative 3 equals 0.8A. So A equals what? Minus
0.38.
0.38 meters per second, right? Now this is the acceleration. Substitute in one of the equations of motion, you can find its displacement, which is?
ليش؟ غلط. Minus 3.75.
Two significant figures.
Minus 3. Chill.
Minus 3.75.
3.8.
So by using this equation, we can find the displacement. V squared equals U squared plus 2AS. V0, U 7.5 squared plus 2A minus 3.75 times S.
S equals 7.5.
S equals what?
7.5.
Sure. Now, if you find the acceleration, right, you can find what?
تطلع عليها 1.25.
Really? Last part is what? E, right?
Minus 1 equals 0. Minus 2.
Yes. Thrust minus 2, 0.5 times minus,
3.75.
yes. Thrust equals
0.125.
0.1. A light inextensible string passes over a smooth what? Pig, and is attached at one end particle of mass m kilograms, at the other end ring also of mass what? M kilogram. Okay? The ring is threaded on a rough equilibrium and rough vertical wire as shown in the diagram. The system is limiting equilibrium with a part of the string between the ring and making an angle of 60 within the vertical wire. Okay? So calculate the frictional force between the ring and wire given your answer to 3 significant what? Figures. Okay? We are given the figure. Actually, it's in a limiting equilibrium, so the particle is at rest, right? The particle is what? At rest. Okay. What are the forces here? Actually here, basically here, weight, mg, tension towards the pulley. Here we have tension towards the pulley. mg downward. Now, I have 2 problems here. With the normal and with the friction. Why? Listen, because we are not given the direction of motion. We are not given what? The direction of motion. Yes, exactly. Now what I have to do before that, I have to resolve the tension. I have to resolve what? The tension. Here, T sine 60, and here, T cosine 60. The angle is given with vertical. Look here, guys, girls, look. Definitely, the normal will be in this side. To balance what? Look, T sine 60 should be balanced because this is what? Limiting equilibrium. Limiting what? Equilibrium. Limiting equilibrium, opposite forces must be equal. So tension T sine 60 should be balanced by certain force, which is what? Normal. And I have to know what? The friction where. Okay? I have to use where is the direction of motion or about to move. Because it's in equilibrium, no matter the direction of the friction. If it's positive, right? If it's positive, if you got the result as a positive value, so your assumption is right. If you got a negative value, so your assumption is what? Is wrong. You should reverse your assumption. Yeah, in other words, خليكم معي شوي. Basically I don't know where is the friction. Since it's an equilibrium, listen, it's an important point. I can't do this unless it's what? In equilibrium. Where can I can anywhere have a friction either upward or what?
Down.
Why? Upward or downward, by the way? Actually, it's either moving downward or what? Upward. This ring, right? Either is moving downward or upward. But I may assume, listen, I may assume that the friction is where? Downward. If the answer is positive, this means my assumption was right. If the answer is negative, this means that I have to reverse my assumption, or if the right answer is the opposite of my assumption.
But the answer is right.
The answer is right, but I have to exclude the negative. I have to exclude what? The negative. When can I do this? If and only if the particle in equilibrium, okay? Because it's not moving. So no matter the direction of friction, okay? So again, I have to do we need coefficient of friction, صح? We need what? Coefficient of friction. F equals what? Mu times R. So I have to find R and I have to find what? Friction. In order to find the mu, I have to find R and what? Friction. So, for the ring, okay, for the ring, what we have forces here, F net upward is 0, right? What do we have here? T cosine 60, right? Minus mg minus friction equals 0. Right? Friction. It's limiting equilibrium. It's about to move, but I don't know the direction of motion. Okay, fine? طيب. F net where? 0, right? T sine 60 equals minus R equals what? 0. So R equals what? T sine 60. So we have to find the tension. We have to find what?
Tension.
What is this? Particle. For the particle, for what? For the particle. F net upward or downward is what?
Downward.
0. Okay? What do we have here? T minus mg, yes, equals 0. So T equals what? mg. We found T. Right? We found what? T. If I found T, I can find everything, right? I can find what? Everything. Now, let's substitute T here. So R equals what?
mg
mg sine 60. So in terms of m, everything, because m is a given value. M is a what? Given value. Substitute this here.
mg.
T, which is mg. Look, girls.
Sine 60.
This one, mg sine 60.
Cosine.
Cosine, sorry. mg what?
Cosine.
Cosine.
Minus
mg cosine 60 minus mg.
minus mu mg sine 60.
Yes. The friction is what? Mu times r. Friction is what? Mu times r. Friction is mu times what? R.
أقسم mg يعتبر
Yes. Minus mu mg sine 60 equals what? 0. What is the only variable here? Mu. Okay? I can divide all the sides by what? mg. 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 Here what? mg. What we will have eventually? Cosine 60
minus 1
minus 1 minus mu sine 60 equals 1.
equals 0.
0, sorry.
Mu equals
Cosine 60.
Yes, mu equals.
0.577.
Okay, I would like to write it in this way. Look here. I will move this here. Becomes what?
cosine 60
1 minus cosine 60
over sine
over what?
over sine
Sine 60. Why I wrote it in this way? Because you may, guys, you may have a question. Look here, please. Show that, I may have a question. Show that mu equals what? 1 minus cosine alpha over sine alpha. Right? I may have a question like this.
بس على فكرة هيك
Well, alpha, this is alpha.
أستاذ هيك غلط.
Why?
لأن هي cosine 60 minus 1 على sine 60.
Yes, because here in the minus. Yes. هون عندنا minus, صح?
minus 1 بدل 1. Okay.
No, not. Clear? Any question about this? Copy this. I can, yeah, I can. Listen. If I got now, if I got negative does not mean
It's wrong.
it's wrong. Actually, even if I did the calculation with the friction on this side, I will have the same value but positive. Right? Both as positive. So I can assume the friction anywhere. Okay? If the final answer is negative, I will positive. I should reverse the direction of what? The friction.